Hello, this is James with Fun Media. I'm here at the beautiful Arkansas Regional with Team 8044 Denham Venom. We're going to be going over this amazing robot and how it's going to just plow through the competition. Today I'm behind the bumpers. So Ethan, you were going to start us off and go over some of the robot?
Yeah, I got you. So one of the things that I think is the coolest thing about a robot is our two-stage elevator with a pivot on the arm. So instead of having a three-stage elevator, which can give us more weight on the robot, we chose to do a two-stage elevator with an arm as a pivot. So if you want to show off, so go for it. Got it? Yep. Yeah, just give me 1 second. So as you see here, our intaking on our coral and our algae. Our coral or algae intake is on the front right here with this band that just basically pulls it back just in case. And we try to do this with other aluminum and other stuff, but it would just pass all the way through. So we switched with this band, which was working really well. And also, as you can notice, this is our coral intake. All these wheels, but all these wheels, it's a very wide intake. We took inspiration from one of the 2023 citrus circuits. So even though we have a wide intake, we can place the coral anywhere. And there's this time of flight sensor right here. So this reads how long or how far away the coral is. And we can use code to basically auto align ourselves to the reef and score very on the reef.
Awesome. So you said that it was two-stage elevator. How high can you guys reach?
We can score on the barge with this little flipper, a little bit outward, and we're able to score the algae into the net itself. So as you see right there, our flipper comes out, and this allows us to score the algae with only having a two-stage elevator. All right, gotcha. Oh yeah.
All right, that's really cool. Sebastian, you wanted to go over some more stuff?
Yeah, so I'll talk about our rear intake that we currently have. This is for algae. We intake algae from the ground here, so it'll go in here and it'll stow inside of this up here. Can you stow it, Evan? And so you can see this will flip out, it will roll into this. This will grab it, catch it, throw it up into here. It'll be held here, and we can either score on the processor, or we can go score in the barge, whatever we decide. We can also flip this out and score a grab from the reef, so we can go score barge or processor, whatever we like. And then we plan on also having another ground intake for coral. We don't have it yet. We have it worked out at home. We implemented it on our practice bot, but we couldn't get it in time. We didn't like how it worked for Arkansas, so we decided not to implement it coming here. But once we perfect that at home, we'll get that on as well. Hopefully have it for our next two regionals. And then we have our climb up here that the elevator will come up a little bit. This thing will flip out. Do you want to run it, Evan? Yeah, I might have to back up a little bit. Yeah, so we'll go up to the stage, or not the stage, the barge. We'll go up to the cage. This will flip out. We'll go underneath, and then we'll grab on to the bottom of the cage with the hook here. It'll orient itself into here, grabbing the bottom here, and then we'll just pull it up. And we have a ratchet on this gearbox back here. Right there, we have a ratchet, so it pulls itself up, and it can't be let go until we let go of the ratchet after the match ends. And to let it spring out, we use these surgical tubing bands. They really elastic, so it helps it flip it out really fast. And then we use this special rope right here, really strong. It doesn't break. We never had it break or anything like that. So yeah, it's pretty nice. Works pretty well.
All right, that's really cool. And then Evan, you wanted to go over some stuff with the programming?
Yeah, of course. So basically the really cool part about this entire robot is the superstructure capability that we have. So all of these subsystems and mechanisms have to interact with each other in order to make it so that none of them hit each other whenever it's moving. Like for example, if the elevator carriage is too high whenever it's flipping the entire arm and claw in, then it'll hit this top bar. So basically what we have is a super movement class, which is just a bunch of logic to avoid hitting and interacting with each like mechanism so that none of them break during matches. Another thing is our inverse kinematics. So basically what we do is we just input a goal angle and goal position, also detecting like the distance from the reef. So like for example, if there's a coral in here, we can detect the distance from the reef in order to like change that goal position and claw position so that we can basically get the coral onto the reef no matter like how far away it is. All you need to do is input the goal position and angle, and it'll automatically just move all of the subsystems to those the needed positions in order to achieve that. That's the really cool part about this, and it's basically like the claw, the arm, the elevator, and the algae intake all have to move synchronously in order to basically achieve what we want to do. All of this is simmed beforehand, so basically in Advantage Scope we can sim the entire robot, transforms and all. For example, if the elevator goes up in our sim, we have it set to go up in the actual simulator. It's a really cool thing to see, and can't show it right now because the power is off for the pit. But basically it goes up and we can actually see where it's aligned in the simulator to see if it's actually aligned with each level so that we can see if it's going to make it on. And that's how we tuned a lot of the measurements and angles in order to put them into actual commands. We simmed everything before even running this robot. And it was really cool whenever it first turned on, and we tuned all of the PID for the elevator, the arm, the claw, and it just worked. It was really cool. It's something that is really helpful for making it really fast and making it really precise, because if we want to change something, we just write it, sim it, deploy it. Same thing for autos. We have full pose estimation, so our trajectory follower in auto will always know where it needs to go in order to follow the auto path to a T. It is really cool.
So you said you had full pose estimation. I noticed that you have 3 unique cameras on the robot, at least that's what I can see. Is that all the cameras on your robot?
Yeah, that's all the cameras.
And how do you utilize them, each one individually for that?
Yeah, so basically there's 2 Limelight 4s, which run the Limelight IMU for like odometry and positioning, but also the April tags for like the pose estimation. And then we have this camera down here, this Limelight down here, for aiming the cage whenever we go to climb. So basically the drivers can see this on a shuffleboard, and they can align up the cage using that camera. And then we have these also on shuffleboard for backups in case something's obstructing it. But these are the main ones that are used for pose estimation. The lights on them are really useful because it generalizes the light between competitions so that it's more consistent and we don't have to like recalibrate it every single time. It's really helpful for that. And yeah, the Limelight 4s are really good. We use MetaTag 2 to do pose estimation, and it is very accurate. Basically, auto scoring is very good. We basically just press a button and it just goes up to the reef, plops it on.
All right, really cool. You guys are doing really well so far at this competition. Plus you have Magnolia next week and then Bayou 3 weeks after that. It looks like as long as you guys continue along this path, one of those events is probably in the bag. All right, that's it today with 8044 here at the Arkansas Regional, today on Behind the Bumpers.